and troubleshooting will be easier for, and BPPC sensing was not there. So mainly we have gone from version 2 to version 3 due to this online monitoring system, because loco position can be known remotely, we can access the data and analyze. So if any problem happens in line, then and there we can download the data from online portal and we can troubleshoot and guide the driver. Actually, FDCS means microprocessor based control system. FDCS means fault diagnosis. Both are same. So this is the block diagram. This is the diagram for version 2. Version 2 means this number of input will be limited 8 cards. Each card will be having 16 inputs, and output cards 5 numbers. That is starting equal for both version 2 and version 3. And these are for power supply card, analog card, interface card. That is for system working. This unit was having the issue of non-availability of remote monitoring system. That is online data, on online monitoring we cannot do. So we have gone for FDCS version 3. And automatically they have revised to revision 3. From April 2018 they have revised, and based on this properly, at present we are receiving FDCS. These are the advantages of version 3 over version 2. First of all, the number of inputs has been increased from 100 to 144. Input BCD functionality. BCD is now inbuilt with FDCS. There is no separate unit required. Real-time monitoring. This is the greatest advantage. For this only they have gone for version 3. And LCD display. Previously, 45 cabin display was there. Instead of that, they have gone for 10.4 inch TFT display. So viewing and scrolling will be very easy. This traction motor current in version 2 it was based on shunt only we are measuring this TM current. Now here power effect sensors are used. So this PP and BC, this sensing was not there in version 2. Here we are sensing with the power effect sensors and taking feedback through ECU. Then locomotive speed, another special separate from a speedometer PG, separate input is given to FDCS to monitor the speed. Then in energy monitoring also FDCS can do. Short term. So based on this, these are the advantages. Better utilization of locomotives, unscheduled withdrawal will be less. Then real-time monitoring will be there. This is the interface block diagram for version 3. This is the main control unit. It has got the communication with the ISCU. These two units are there. It has been provided V1 panel and V2 panel. Each V1 panel TM current will be sensed through Hall effect sensor, and this feedback will come here. And from here it will communicate to control unit. Then signal conditioning will be there. All the analog parameters like voltage, output current, this speed, R0, SI voltage, R0 voltage, everything will be sensed through SCU. And there will be one antenna. Through this antenna only GPS communication will take place and online monitoring is possible. Then there are two LCD TFT screens in both cabs through which a driver interface. Any information or messages can be shown to driver, and he can also take some actions like wedging some relays. Then notch encoder will be there to show the absolute position of the passenger position. Then 9 input cards will be there, 5 output cards. Through these input cards only we are taking feedbacks from all the circuits. Previously relay interlocks was there. Through that interlock only circuit was sensing that this equipment is functioning normal or not. Here instead of that interlock we are using input from each interlock. That interlock supply will come to locomotive SB. From SB we can give to input card. So input card will sense whether this function has been worked. Suppose if banner is raised, whether banner has been raised or not. That input supply should come and it should be read by this card. Like that output cards is also there. For some combinations of circuit working, particular input conditions are satisfied, means then system will give the output. So output will drive the our contactors, relays, VCBs, etc. automatically based on this circuit condition. All the input conditions are satisfied, then only output will be given. And one analog input card is there, that is for decoding the notch encoder data. And the two control cards will be there. This is the main heart of this unit. So all the processing and recording and data transmission will take place here. Then two power supply cards to provide power supply to the entire unit. 12 volt, 7 volt and 5 volt. Both power supply cards will be hot standby. So if one page means another automatically will take. Reset switch will be there. These are the input cards, output cards. So CPU cards, there will be two numbers. At a time, one card will be master and other will be in standby mode. Whenever DJ tripping takes place, automatically this will switch over. That is, master card will go to slave mode and slave card will go to master mode. Then there are the input modules, input cards. 9 numbers of input cards are there. Actually, one card will be redundant, 7th card will be redundant, and one card will be spare. So total 7 cards we are using. Spare card provided for future expansion. Then output cards, 5 numbers will be there. Analog input card, 1 number. Loco remote monitoring module. This card only communicates with that GPS. So even though FDCS is helpful for analyzing and troubleshooting and reducing the download failures, it is a software operated system and it is prone to malfunctioning. So incidents will come such that the system will not allow driver to open the DJ. So that is an unsafe condition. So we have to avoid such conditions. For that, RDSO has given some modifications to trip DJ and pantograph. Some manual interlocks we have intentionally put in ZPT and DJ circuits. For example, BPMO switch. All the FDCS logos are provided with the BPMO switch. If any malfunctioning, suppose if anything is happening, means driver needs to trip the DJ and it is FDCS switch off the VLDJ switch, but FDCS is not tripping DJ. Then he needs to put the loco to stop. For that, he needs to apply brakes. So for that, BPMO switch has been provided. Hardwired interlock, no soft logic. Once that switch is pressed means then output of DJ is automatically cut. So even though it is advantageous, still we are going for old relay based logic for safety reasons. Now we are coming to fault data. So in case of any abnormality, in locomotive system, fault messages are be displayed. First, this display should be given to driver. Then only driver will be able to know what is the issue, where is the issue. So first, to attract his attention, FSCW will be glowing, this DPFM will be glowing, and with that appropriate message will be displayed in display. So driver first incident, his attraction will go to display. Then buzzer. Buzzer 3 frequencies are defined. All these for diagnostic messages, overspeed and vigilance alarms. All are through single buzzer. So each buzzer or each function different frequencies are defined. With that, we can identify this is a diagnostic message or overspeed or vigilance alarm. Retrieve, and when logo comes to send means we can download and we can analyze also through authorized software only. This system is equipped with USB 2 host port. Through this USB port only we are downloading and we are analyzing data through software. As per DC119, this RDSO spec 001 version 3, these are the inputs. We should be available for the background for every fault. Total 24 faults are there, 24 parameters are there. All the parameters, these parameters should be available for each and every fault recorded in CPU card. We should be able to know because With this only we will be able to analyze. It has been clearly defined in specification. Based on this only they have developed the software. In addition to these 24 parameters, following also required: date and state, date of occurrence and time, which time to be there, VCD penalty, VCD status will be there, distance and locomotive GPS. Continuous message only indication and storage will be there. This readability and fault chain troubleshooting, this priority on message diagnostic. These are the different parameters of fault message. If any fault message is there, then it shall be displayed along with buzzer and LSFP. Then driver has to acknowledge by pressing the input switch. This will turn off the buzzer, and in case of priority 1, LSFP remains glowing. Priority 2 fault means this everything will be going to normal. And all the parameters shall be recorded in the data. Total of 1024 faults can be recorded in fault data with this background data. And for this background data, for troubleshooting input and classification of input and output signal and grouping them, it has been divided into various subgroups. So these are the subgroups. Based on these subgroups only, they have defined the fault messages. So subsystem number 1 is main power circuit, 2 is auxiliary power circuit, 3 is auxiliary power control circuit. Like that 8 control circuits they have defined. These are the details of fault messages. Total 190 fault messages have been defined. 190. I have from some sample only. So this is the fault. Message stored for fault. Details put away POP. So details put away POP. So driver will experience detail to with this message display. Then what driver has to do? Check safety relays, QRSA, all the safety relays he has to check. If QLM is active means then he has to follow local instructions. And if there is no QLM, reset QP and testing fraction. First instant, you should follow this. Then if again reset means, then if any TM is a faulty means he has to isolate the faulty TM by HNCS. Then if HNCS, this also not solving the problem means, then HTOP has to be put into 0 position. So troubleshooting directory will be made based on this only. Likewise, all the power circuits, all the faults it has been defined. Here they are shown power circuit, auxiliary power circuit, all the subsystems, all the faults has been defined. Each and every fault, what he has to do, what message will come, why this message is come. We just put away QRSA. Then the reason is overcoming rectifier block. This will not be shown to driver, but we should know. It means maintenance people should be known why this message is coming. So this is the fault messages. These are isolation messages. Total 190 messages, 5 are isolation messages. These are if any system, this equipment is isolated means then system will display isolation message. That's all. This is not much importance to maintenance point of view. This is as per TC 119. RDSO has clearly defined what are the messages to be grouped as fault, isolation and information. Based on this only, they have defined there. This is information messages. Information message is driver for driver information only. It will be also stored in data. Total messages are there. All the messages are given a diagnostic code. This code will also come. So based on this code, he can identify each. Next we are going for background data. So background data already I have told 24 parameters. It should be available in all the fault data. For 5 seconds before and 3 seconds after. And each packet data shall have the location information and the VCD and penalty application program. If redundant is active, that also should be able to. So if any fault which is defined in subgroup 1. This coming means then all these inputs should be mandatorily available and these outputs. That means if any fault, one fault occurred which is falling in subgroup 1. Now we are going for data analysis. Data analysis through pendrive we are taking data from FDCS. It's a data condition. And after analysis we have to analyze the request software. Here we are taking MEDA. MEDA FDCS software firm is giving and we are analyzing through the software. After putting in pendrive, here on download option is there. Window will come like this. Here we have to select the local number. Here we have to select all type messages with the data pack. Here different options are there. One long term event recorder and short term event recorder. So some particular parameters, some 27 parameters are defined by RDSO for long term and short term recording. Long term recording 20 seconds interval will be there and short term recording per second interval will be there. Apart from that, if any parameter is actuated means that also will be recorded irrespective of time. Here we have to select this local number. Then it will ask for start date and end date. From which date? Because schedule to schedule we are analyzing that date we can put and we can go for search. Then it will be like this. It will come like this. This is the default setting. Here a group wise display here. This is displayed with group wise because the particular fault how many times it has occurred. Okay. Here auto-location way 2D to 4. This is the maximum times. Likewise, if any incident is happening frequently means that it will be able to easily identify through this. So here first we will go for the number of occurrences. Then abnormal occurrence means then we will highlight. Also here we can group the fault with entire fault also one option is there. Here if we select means then we will get the date-wise fault, date-wise and time-wise arrangement. So particular date, particular time, what was the occurrence means we will know means then we have to select this entire fault and here we will be selecting the our record time. Normally this will be in fault occurrence mode. Here this we can select and here the short term memory and long term memory has been defined. The short term memory some 27 parameters has been defined by PC109. These parameters will be recorded per second. Each second these parameters will be going on recording. If it is short term means then 24 hours data will be available in this short term. Here per second recording will be there, but within that 1 second, if any of these parameters is active means that also will be taken. Likewise long term also. Long term 20 seconds interval will be there. Same parameters only. Latest one RDSO modification is there 498 that cluster operation. An accident was there and CRS inquiry it was not able to identify whether driver has operated cluster or not. So they have provided one modification sheet to incorporate the cluster light operation should be added in this long term and short term. Here on loco. Then we are suppose we are analyzing one fault data of a schedule loco. Selecting these parameters, we need to know what parameters we need to check up for this fault. So for that we need the subgroup. Then we will go for background data. For viewing the background data, we have to select this any particular data double click. Then it will come like this. So here we need to know for this fault what are the inputs and outputs we need to analyze. For that, these inputs already defined in DC119. Based on this only he has developed this. Suppose if input card number 1, what are the inputs? Same only he has incorporated software. So before selecting these parameters, we need to know what parameters we need to check up for this part. So for that we need the subgroup. Here QVSI input is I55 and I56. These are the inputs. So your message is DJ reply QVSA button. That means this input is not active, or FDCS has not sensed that QVSA feedback. So data we first we will select the QVSA, whether this is correct or not. DJ reply QVSA. So here QVSA is open. But QVSA 2, second run it is showing on. Okay. So what data is telling is correct. Like the we will see. Then next DJ deploy QVSA. So DJ has filled or not. So that we will check the DJ input. So DJ, here DJ, this is the I60 is the DJ input. This is the port account 10 1138 to 42 1138 42 is as DJ deploy QVSA. What the system is telling that we have analyzed and it is found to be correct. But mainland side we need to analyze deep. For that we should be thorough with the circuit. Actually these are based on FDCS inputs and outputs. These circuits have been developed from our conventional loco circuit. So conventional loco circuit we should be thorough. So DJ tripping via QVSI, when it will come? When we take first node. Here these are conventional loco circuit. Here GR0 parallel interlock is parallel. So until GR is in 0, it will not true. 244, it will not true. If when GR is moved from 0, then QVSA has to be picked. GR moved from 0 means he is taking notes, first note. So here we have to analyze whether he has taken notes or not. Yes, this incident, he has taken notes. So that is correct. As per logic, QVSA is tripped, DJ has been tripped, note number notes he has taken. Before taking notes, driver has to ensure that SIV has been picked up or not. How he will know SIV picked up or not? Through LSAP indication. So we have to go for LSAP. Whether this LSAP has been extinguished or not. At this instant it has been extinguished. That means driver has taken notes after execution of LSAP. That means SIV has picked up. What he has done is correct. But here QVSA is off. Then any issue with the arm or SI voltage, because after LSAP extinguished only, because here the voltage will be is normal only 15 volt. That is normal only. Charger also started working. That's why LSAP has been gone to off. Then Q1 also, SI output voltage is confirmed. So SIV side is okay. What driver has done is also correct. After SIV picked up, LSAP extinguishing, he has taken one note. Okay, but that time DJ has tripped. So what we will assume this is due to a problem with the QVSA. The relay has not picked up. What driver has done is correct. But one more thing, whether it has happened in testing or not. Here PPO will do testing. That time what they will do? Purposefully they will isolate one track and they will check. So for that, whether testing time this has happened in testing time or not, that for that we need to take these two inputs also, HMD or not HMD. So here, actually these two inputs depend. It's one track. HMD 1 HMD 1 and 2. These two inputs depend one track, and HMD 2 and 2 in 1, 2 in 2. This depend second. So here HMD 1 in 1 means normal position only. Here also HMD 2 in 1 normal position only. So that means testing time, this they are not disturbed. Okay, HMD truck both trucks are in service condition. Driver has taken notes after SIV pickup only. LSAP extinguisher has verified and he has taken one note, and that instant itself DJ has been tripped. So what we will assume, what our conclusion is that all the parameters done by all the sequence of working done by driver is correct. Testing has not taken place. So probably there might be a defect with the relay power. So this is our conclusion. Node sequence is verified as per circuit. After SI pickup, LSB is usually stated nodes. Truck 1 also was not in isolated condition. That means no testing was taken place. Both bogies are in isolated service condition. Still QVSI feedback is not available. Here QVSI is permanent off only. And similarly in the road may be having issue. That is our conclusion. Apart from this, two other chances are there. Cable issue. This input cable coming to SD might be having issue means then also this circuit will not work. Next, FDCS input card channel. As engine channel defective means then also it will not work. But in these two cases, it will be permanent. So driver booking will be there. Here we have to check go for logo, whether this is permanent or not. But from data itself it is. So for each data analysis, these are the points you have to keep in mind. First we have to check the logbook, because what the fault is experiencing. Driver is our primary input. What is experiencing, we have to talk and we have to get from logbook. Because what he has experienced in line, we may not experience here. So his words should be given importance. Then date and time, whether it is matching with our GPS time, where you have to analyze. Then relevant parameters. What are the relevant parameters we have to select? That should be known if only the circuit is covered. Then only we can able to know which parameters has to be selected. Otherwise, if we miss one means, then we will not be able to identify. Then analyze all possible combinations for the fault occurrence. Then arrive at a conclusion. Then if we are arriving at a conclusion, then we have to give the proof through data. This has happened due to this.